अस्सलाम वालेकुम।
अस्सलाम वालेकुम सर। वालेकुम अस्सलाम।
वालेकुम अस्सलाम सर।
सर एक बात पूछनी है।
जी हारिस
सर ये क्विज हमने सबमिट किया लेकिन मार्क्स अभी तक उसने नहीं बताए। वो कल जो क्विज हुआ था लड़के कह रहे थे हमें मार्क्स उस वक्त पता चल गए थे और हमारे इधर अभी तक नहीं आ रहे।
क्विज के मार्क्स जो है वो फिलहाल हमने नहीं डिस्प्ले किए, वो रिजल्ट बनेगा तो फिर डिस्प्ले हो जाएंगे।
ओके सर, ओके, थैंक यू।
अस्सलाम वालेकुम। आवाज आ रही है जी?
वालेकुम अस्सलाम। जी सर, आवाज़ आ रही है।
ओके जी। Let's wait for 1 minute and then we will start. Okay ji, so the next chapter is bipolar junction transistor. Okay, as you can see, bipolar junction transistor. Now, the bipolar junction transistor means we have basically a device which has got two poles, and the two poles are here. If you remember, in the PN junction diode, we discussed that there is a flow due to the free electrons which are in the conduction band, and then there is a flow due to the holes which are in the valence band. So in the bipolar junction transistor, or in the transistor, we have got the flow due to the electrons which are the free electrons, as well as the flow due to the holes which are in the valence band, right? So therefore it is called bipolar junction transistor, that the flow which is taking place in case of a transistor is both due to the free electrons which are in the conduction band, as well as the holes which are in the valence band, right? Okay, so in case of a transistor, what we have, if you remember, we have basically a diode. So diode has a junction. Now if we have, let's suppose, a diode, so diode is having a junction like P and N, right? Now if we have got two PN junctions, this means if I say I have another PN junction, right? So, and if we combine these two PN junctions, so there are two ways to combine it, right? So either we are going to have the combination, it is going to be either we will have combination like P, N and P, or the combination will be N, P and N. Are you with me?
Yes, sir.
ठीक है जी. So some people, they have joined just now, so let me repeat it. Okay ji, so today's topic is bipolar junction transistor. Bipolar junction transistor, as if you remember, in case of diode, we had a flow due to the free electrons. Free electrons, they are always in the conduction band, and there is a flow due to the holes. The holes, they are in the valence band. So the transistor has got a flow due to both the free electrons as well as due to the holes which are in the valence band. So if, let's suppose, if we have got a PN junction and another PN junction diode, and if we want to combine it, we will have either we will have a combination like PNP, or we will have a combination like NPN, right? Are you with me?
Yes, sir.
Okay ji. So if you can see, the combination PNP or NPN has some names for them. So the first P over here, which I have just mentioned, this is called emitter, with E. It is labeled as E. The one in the middle, this one, this is labeled as B, and the one at the side is called collector, which is C. Now, emitter is actually the one which is heavily doped, right? The middle one, the base B, is, you can see, it is very narrow in size, as well as it is lightly doped. And the one on the side, which is the collector, see, it is moderately doped, right? So we have the emitter E, which is heavily doped. So I can also write out here for NPN, the emitter E and the collector C, right? So either we can have a combination P and P, or we can have a combination NPN. Now, the first P or N, they are the emitter, which is heavily doped. The middle one, the base, which is lightly doped, and the size of the base is comparatively very, very thin as compared to emitter and collector. And the collector on the other end is moderately doped. Okay. G, question?
यस सर।
G.
सर ये हेवीली डॉप का क्या मतलब है?
हेवीली डॉप्ड का मतलब ये है कि डॉपिंग आपको याद है जो इसमें हम डायोड में डॉपिंग करते थे?
नो सर।
डॉपिंग नहीं याद? डायोड नहीं याद?
नहीं सर, नहीं है। डायोड याद है।
हाँ जी, तो डायोड में डॉपिंग होती है ना, जो हम इम्प्योरिटी ऐड करते हैं।
यस सर।
तो अगर वो इम्प्योरिटी के एटम्स हम ज्यादा ऐड करें तो वो हेवीली डॉप्ड होगा।
ओके।
मतलब जब
Excuse
हम
me, sir.
just hold on, let me finish.
Oh, okay, sir.
So when we heavily doped it, this means we will have plenty of free electrons, they will be generated due to the doping, right? If
ओके सर।
if we say it is moderately doped, so this means have the majority carriers, they will be in the limit, right? And when we say it is lightly doped, so this means there are few majority carriers, they are being generated due to doping. Are you with me now?
यस सर।
Okay, Ji.
Excuse me, sir.
Ji.
Assalamu alaikum, sir.
Walaikum assalam. Question.
Sir, I want to say something. Sir, question नहीं sir, अभी जो quiz हुआ है हमारा सर, उसमें 20 minutes का time दिया गया था सर। हमारे classmates और section है कि जो हमारे सर जो friends है सर, ज्यादातर लोगों से quiz miss हो गया क्योंकि उनके internet issues थे सर, और बहुत से लोगों ने सर quiz नहीं दिया है सर। तो please उनके लिए सर अगर quiz दोबारा arrange किया जाए या फिर उसी quiz को मतलब सर अगर उनको दोबारा send कर दिया जाए ताकि वो quiz दे सके, क्योंकि group में लगे हुए सारे और इंटरनेट इश्यूज की वजह से किसी की लाइट नहीं थी तो किसी के पास इंटरनेट का मसला था, तो वो किससे रह गए हैं सर।
अच्छा चलें, ये अब क्लास के बाद डिस्कस कर लेंगे, ठीक है जी?
ठीक है सर।
ओके, थैंक यू। Okay, so we are discussing the transistor. In the transistor, we have either PNP or NPN, right? If we are going to see the symbolic representation of the transistor, so symbolically the transistor is being represented as having three legs. So one is the collector, the other one is the base, and the third one is the emitter, right? So if we say this is PNP, right? If we say this device is PNP, so we will represent it as this with an arrow towards the base. This means the base is of N type, right? If we say we have a transistor which is NPN, right? So this is the base, this is the collector, and this is the emitter, right? So this means that the emitter is N type, right? So this means the arrow will always be indicating towards the N type, right? So in this way we can differentiate between the two transistors, either it is PNP or either it is NPN. Are you with me?
Yes, sir.
Yes, sir.
Okay. Now if we take a look of the transistor, if we say we have a transistor NPN, let's suppose, right? And initially we have said that the N, P, and N, and this one is the emitter which is heavily doped. Then this is the base which is lightly doped, and this one is the collector which is moderately doped, right? So to have the normal operation of the transistor, as you can see, there are two junctions. One is the junction which is in between emitter and base. So what we say, this we call it emitter base junction, right? And then there is another junction which is in between the base and collector. So we can say base collector junction, right? Are you with me?
Yes, sir.
Yes, sir.
Okay, thank you. So to have the normal operation of the transistor, the emitter base junction, the first junction needs to be forward bias, and the second junction, which is the base collector junction, that needs to be reversed bias. So for the normal operation of the transistor, these two junctions needs to be, the first junction need to be forward bias, and the second junction, which is the base collector junction, need to be reverse bias. Now let's see what happens that if we make the two as mentioned to have the normal operation of the transistor. So let's see if we are going to make it the emitter base junction forward bias, right? So what will happen? If we make this emitter base junction forward bias, so applying some DC source and making this junction forward bias, right? Now, as we have said that the emitter is heavily doped, right? So when the emitter is heavily doped, this means we will have plenty of free electrons. They will be generated, right? And we have also said that the base is lightly doped and the size of the base is very thin as compared to the size of the emitter. So this means we will have very few majority carriers which will be there in the base, right? Because in the N side, the majority carriers are the free electrons which are in the conduction band, and on the P side, the majority carriers are the holes which are in the valence band, right? So let's suppose we say the biasing over here is VEE, right? Now what will happen? That if we forward bias the base emitter junction, so this means the free electrons on the N side, they will start moving towards the P side, right? So this means the majority carriers from the emitter, they go into the base. Very few of them, they will be able to combine with the holes, and once they will be able to combine with the holes, so they will actually flow through the base and they will constitute the base current. But the rest of the free electrons, they will be moving across the junction, which is the emitter base junction. They won't be able to get into the hole because the holes are limited in number as compared to the free electrons which are being generated by the emitter, right? So only very few of the free electrons, they will get into the holes. The rest of the free electrons, they won't be able to get into the holes, right? So they will be just be occupying over here. They will be getting over here, right? But they don't fill up the holes. Are you with me?
Yes, sir.
Yes.
Right? Now, if we again see that the same thing, and if we say we had the N, P, and N, right? So this is our emitter, this is our base, and this is our collector. Now, again, to have the normal operation, we need to have the base collector junction need to be reverse bias. Now, how we can make this reverse bias? That we provide the biasing in such a way that the collector is being connected to the positive side and the base is being connected to the negative side of a DC source. And we say, let's suppose the DC source is VCC, right? Are you with me?
Yes, sir.
Ji. So if you see, the base collector junction is now reverse bias, right? So it should behave like a diode which is reverse bias, right? Do you remember that?
Yes, sir.
The diode which is reverse bias. So if you see the majority carriers from the N side, they will be attracted by the positive end of the DC source, right? Because this end is positive. So when it is going to be attracted, so this means the width of the depletion region, it is going to increase in size, right? Because the majority carriers, they are not attracted towards the junction, but they are attracted towards the poles of the biasing source, right? So due to that, the width of the depletion region is going to increase. Now, this is the function of the majority carriers. What about the minority carriers? Now, the minority carriers on the base side is basically the free electrons which are generated due to the whole pair creation. And similarly, over here, we have the minority carriers as holes over here in the valence band. Now, these minority carriers, as they are being pushed towards the junction, and as if you remember, they are going down the energy hill, so simply they will just push through the junction, they will go over here and they will constitute a current, which is over here is normally called as IC minority current, or the collector current which is flowing due to the minority carriers, right? Are you with me? Or this was normally called as the reverse current in the diode. Can you hear
Yes,
me?
sir. Yes, sir.
ठीक है जी. So what is happening that there is a small amount of current due to the minority carriers due to this biasing, and then if we combine the effect, if you see previously we have shown that due to the majority carriers, the once the emitter base junction is forward biased, so the majority carriers they will cross the emitter base junction, and very few of them they will constitute or they will get into the holes at the base, and they will constitute a current over here which is normally called IB, which is the base current. Because if you see, the conventional direction of the current is always opposite to the flow of the electrons, right? So therefore I have made the arrow in the opposite direction to the flow of electrons. Are you with me?
Yes, sir.
ठीक है जी.
Yes, sir.
And similarly, if you see, the current in uh, the base collector junction is due to the minority carriers over here. So the electron flow is in this direction. If you see, electron flow is in this direction. So this means IC minority will be flowing in this direction, right?
Sir, repeat करें, इसकी समझ नहीं आई.
Acha ji. Okay, let's see it again. What I am saying, that the emitter base junction, we have the flow due to the majority carriers, right? And once the majority carriers they pass the emitter base junction, very few of them they will constitute the base current, or this means they will get into the holes which are the majority carriers on the base side, and they will go through the base and they will make the base current IB. Now, the conventional direction of the current is always opposite to the flow of electrons, right? Because the electrons, they are flowing like this. So this means the conventional direction of the current is always opposite to the flow of electrons. So therefore, I have mentioned the direction of IB opposite to the flow of electrons. Similarly, if you see the flow due to the minority carriers, the minority carriers on the base side is electrons. The electrons will cross the junction and they will get into the holes on the collector side, and very small amount of electron flow will be there, and due to that we will have a current which is flowing over here is called IC minority. And IC minority is basically having the direction again opposite to the flow of electrons. So therefore I have shown the arrow like this over here, right? So if we try to combine the overall effect of both of the DC biasing to both of the junctions, the emitter based junction and the collector based junction, so let's see the combined effect. What is going to be the combined effect? Let's see. So we have N, P and N, right? And this N over here is emitter, this is base, and this is collector over here, right? Now what we are doing, we are forward biasing the emitter base junction and we are reverse biasing the collector base junction, right? And we label them as VEE, the DC source, which is biasing the emitter base junction, and VCC, which is providing the biasing to the collector base junction. Okay, Ji. Now, as we have said that due to this VEE, we have the flow of the majority carriers which will take place, and that will go and pass the barrier potential, and very few will occupying the hole over here, and this, due to this occupation of the holes over here, it will create a current over here which we say that is IB over here, right? Now as you can see, the biasing at the collector over here is positive, right? Now we have now plenty of free electrons that are being in the base now, and as we are applying positive potential at the collector, so this means these free electrons which are at the base, they will pass the uh, the base collector junction and they will be able to be collected at the collector of the transistor, right? So now this means that majority of the electrons or the majority carriers that were emitted by the emitter, they will be collected at the collector, right? So therefore the names, the emitter, base and collector, they are being given to the three. That emitter that emits the majority carrier, the base is at where very few of the majority carriers they are being collected, and the majority of the majority carrier they are being collected at the collector of the transistor, right? So if you see that due to this we have basically a current which flows over here is IC, right? Are you with me?
Yes,
Yes,
sir.
sir.
ठीक है जी. So if you see that there are, we can see two currents they are flowing. One current is flowing at the base of the transistor, the other current which is flowing is at the collector of the transistor. So this means if you apply Kirchhoff current law on this transistor, so the total current which is flowing, it will be actually equal to IE, which is basically the combination of, you can say, IE to the equal to IB of IC, right? Are you with me?
Yes, sir.
Yes, sir.
ठीक है जी. Now if you can see that a very small portion of the majority carrier, they are being collected at the base. Normally okay, normally the values of the base, they are in the range of microamperes, and the collector or the emitter currents, they are in the range of milliamperes, right? So this means that the overall impact of the base when we are looking at the milliampere range is very, very small, right? So we can even say that IE is almost equal to IC, right? Are you with me?
Yes, sir.
And when we take a look of the collector itself, which is IC, so what we can say that IC is actually equal to IC majority plus IC plus IC minority, right? So this means that the collector current is actually the combination of the minority carriers as well as the combination of the majority carriers, right? Because if you see, we have this where the part of the collector current is due to the minority carriers and a part of the collector current is due to the majority carriers, right? So therefore we say that the collector current IC is actually the summation of the IC majority plus the summation of IC minority. Are you with me?
सर
Yes.
जी
सर ये कलेक्टर बेस्ड जंक्शन तो रिवर्स बायस है ना
जी जी
सर तो इसका ब्रेकडाउन हो गया कि मतलब ये जो इलेक्ट्रॉन पास हो गए इससे
ओके, यही तो मैं आपको शुरू में बता रहा था, आपने लगता है आप मिस कर गए हैं. ओके, what we have
जी
said that, can you see this?
यस सर
So we started with that to have the normal operation of the transistor, the emitter based junction need to be forward biased